Hey everybody, it's Mrs. Gifford again, and we're going to continue working on our lessons with combining terms. Today I'm going to add in coefficients and exponents, and we're going to multiply them together, use our rules of exponents, and then also simplify and look for like terms like we did back in lesson 1. So after this lesson, you will be able to combine like terms when multiplying terms with coefficients and exponents. So let's just get right into one vocabulary term. Again, grab your vocabulary packet or go to the M page in your vocab. And the one term for this lesson is monomial. And a monomial, this prefix mono, M-O-N-O, meaning one, is an algebraic expression that has just one term. So like 3x, that's a monomial. The number 12 is a monomial. There aren't any mathematical operations between each of these things. 3 plus x is an example of a non-monomial. This is actually a binomial because it has two terms. So today we're just going to work on multiplying terms like this. So let's get right into the examples. Hopefully you took a minute to pause the video and put that term in your vocab section. So here's the first example. We're just going to simplify each of these expressions. So again, go ahead and hit pause, and then you can get the example written down, and then we will get into the examples. So we're back, and again, we're going to simplify each of these expressions, and we're going to use our rules of exponents. First of all, we need to take a look. What I like to do is look at the variables. And we have a z, and we already know that anytime we have the same base, we are simply going to add those exponents. So I know that z is going to be the only variable in my product here. And I think we've already mentioned it before, but anytime you don't see an exponent right here, it is considered a 1. And what's the rule for multiplying monomials when they have the same base? What do we do with these exponents? Right, we need to add them. So this ends up becoming z to the third. One of the things that you can do if you feel like you need to is write it out as a problem like this. And that comes from the fact that z squared is z times z. And then we have this other z that's all by itself in parentheses. And so there's 3 of them. In case you're wondering why my z's look so funny, I like to draw a line through them so that sets them aside or separate from the number 2. So here's another one. Again, y to the second times y to the 8th. Again, we just have y as that variable, so y is going to be in our answer. And just like the one up above, once you recognize that you have the same letter here, you simply add those exponents, and 2 plus 8 is 10, so the y to the 10th. Why don't you pause the video real quick and walk yourself through C and D and see if you get the same answers that I do. Okay, we're back here with C and D, and we have p to the third times p to the negative 10th, and if I was doing this problem, I would get p to the negative 7th for letter C. Again, once you recognize that the variables or the bases are the same, you can simply add those two exponents together. And we just got done reviewing 3 plus negative 10 is negative 7. And the last one actually ends up becoming one of two things you could put. You could either have it as be a to the 0, or does anybody remember what anything to the 0 power equals? If you said 1, that is correct. So anytime you simplify expressions and you see a variable to the 0 power, you could leave it as this, or I guess I would prefer it completely simplified to be 1. So keep that in mind as we move into the second example. Again, go ahead and hit pause, and let's walk ourselves through example number 2. Oops, I made a mistake and forgot to get these. Okay, so I'm back. I just had to fix the information here on this slide because I had forgotten to make them as exponents. So we're going to take that same idea that we just did in the previous example, and we are going to apply it to this one. And everything that we just did, sorry about that, everything that we just did in the previous example is going to hold true for this one. The big idea is to look for the same base, add those exponents, and then simplify as best as we can. So t and t to the 5th, remember there's an invisible 1 right here as that coefficient, so this one becomes t to the 6th, and here's a t to the 6th, and just like an invisible 1 exponent, the coefficient of these is 1, and so completely simplified, if we have 1t to the 6th plus 1t to the 6th, we have 2t to the 6th. So completely multiply and then look for any like terms with same base and exponent, and then simplify like we've done before. Again, here's v to the 1, or v to the 1st power, so this becomes v to the 10th. It's a 10. And then minus v to the 7th plus v to the 10th. Again, when you multiply, the exponent changes. The next thing that I notice is I have a v to the 10th here and a v to the 10th at the end, and so I can add them together just like the one up above, and this becomes 2v to the 10th, and then we can't forget our minus v to the 7th. Again, different exponents, we can't do anything else with it. Example C, we have w to the 4th times w squared. Add those exponents, we get w to the 6th plus, we have w to the negative 3rd times w, and again I'm just going to remind you that coefficient is 1 on these plain w's, and this gives me w to the negative 2nd power because negative 3 plus 1 gives us negative 2, and I have this minus w. Now I look down the line and I say, okay, I've got w to the 6th. Do I have any other w to the 6th? No. I've got w to the negative 2nd, nothing else, and then I have just this plain w. So completely simplified, it would be w to the 6th plus w negative 2nd minus w. Last example, then we'll move into our summary. So this first term becomes u to the 10th. Again, that plain u has an invisible 1 as its exponent. Oh, that should be a u. Let me change these real quick to u's. Sorry about that. And we're going to do the same thing we did in this one, in the previous one, and all the other ones, quite frankly. And we are going to simplify this. So we have minus u to the 9th plus u to the 9th. And again, just like we did before, I'm going to look for like terms. Here's u to the 10th. There aren't any. And actually, I have a negative u to the 10th plus, or excuse me, negative u to the 9th plus u to the 9th. What happens to these guys? Right, they end up canceling because we have a negative 1 u to the 9th and a positive 1 u to the 9th. So u to the 10th is your answer here. Let's finish this lesson here by writing our summary. Just like previous, we're going to write a little paragraph about the focus of this lesson, and you're going to talk about what you learned. Show us an example, make your own example, and why does this work for what we've talked about, and then what question that you have. That's it, folks, and there will be more to come on the next day.